Student, today I am going to discuss about electrical resistance. Before I start about this one, I have discussed some before lecture, that is about relation between electric current and drift velocity. You know, drift velocity equal to EB by ml into tau average. Here E is the what? Charge of electron. V is the potential difference across the two ends of the conductor. M is the mass of electron. L is the length of the conductor, as well as tau is the relaxation time. Clear? Similarly, as we know, the current which is equal to NEA VD or V naught. N means number of electron per unit volume, E means charge of electron, A means area of the conductor, and VD means drift velocity. Okay. So this is the formula of drift velocity as well as relation between drift velocity as well and electric current. So whenever I define electrical resistance, so I will consider a conductor. So this is a conductor. What? This is a conductor. As you know that conductor connected to a potential difference or battery, so that the two end of the conductor generate a potential difference V, and that is generated 0. That means the difference between V minus 0, which gives, or the difference between V and 0, which gives the total potential V, which is found from battery. Okay. So here one end is potential, higher potential, and other one is lower potential. That's why potential difference is the difference which is required to continuously and steadily flow of electric charges inside the conductor and in a given circuit. As you know that already I have discussed that thing. Okay, clear? So so whenever the number of charges flowing from one end to other end, oppositely there is a current which is drawn inside the circuit. You know that thing. Okay. So here a new term becomes generated while in between potential and current. That term can be represented as electrical current, electrical resistance. So here we define electrical resistance. So what do you mean by electrical resistance? Why we called resistance? Resistance means what? कौन रेजिस्टेंस आम पाखरे रेजिस्टेंस अछि तार अर्थ हम कोन करिबा किछि कार्य करि परिबा हम पाखरे सेति बळ अछि बळ केतबेल पाइबा जेतबेल हम खाइबा जदि खाउ खाउ जदि अधिक खाइ देले कोन हबो हमको कोन देह हमर देह खराब हबो सेही भଳି हमको जेति की लिमिट रो खाइबा दरकार सेति की खाइबा दरकार तार अधिक खाइले कोन हबो देह खराब हो सेही भଳି गोटे कंडक्टर रे जेतिकी अमाउंट रो करंट जीवा कथा सेतिकी जीवा दरकार गोटे पार्टिकुलर गिवन पोटेंशियल रे जदि ताठरो जदि अधिक अमाउंट रो करंट जाए से करंट को अपोज करिबा शक्ति गोटे थाए से करंट को जणे के अपोज करे ओके से गिवन सब्सटेंस रे से जो अपोज करिया शक्ति जहार थाए ताकू कहा जाए रेजिस्टेंस ओके कोटी inside the conductor. Is it clear to all? So the electrical resistance is the net opposition offered by the conductor whenever the current flow through that given conductor, or is a property of electrical circuit which oppose the electric current where the current passing through that circuit. Okay, so electrical resistance को हम जब define करिबा तो लिखिबा it is the net opposition offered by the conductor when the current pass through that conductor, or it is the property of a material or substance. It is the property of a substance which obstruct the electric current, or ame likhi pariba it is the property of a substance which obstruct the electric current. Clear? तारथला जदि आमे गोटे कंडक्टर रो एक्रॉस जदि पोटेंशियल डिफरेंस दबा बा पोटेंशियल को रखिबा ताहले से पोटेंशियल रे काम हला से जो चार्ज जाको अछि ताकू से फ्लो करेबो जो फ्री चार्ज रहिला कंडक्टर ताकू से फ्लो करेबो जदि गोटे कंडक्टर भीतर फ्लो कला कि फ्री चार्ज तार तो अपोजिटली कोन हबो करेंट फ्लो हबो तार तो करेंट गला जदि अधिक परिमाण रो करेंट गला से अधिक परिमाण रो करेंट को जेतिके जीवा कथा सेतिके जीवा बदले अधिक अमाउंट रो करेंट जीवा बेले सही करेंट को ए जो इलेक्ट्रिकल रेजिस्टेंस कोन करे अपोज करे ओके बुझी परछो तेनो रेजिस्टेंस मींस सहाय करिया शक्ति तेनो इट लेखा गला इट इज द प्रॉपर्टी ऑफ ए सब्सटेंस व्हिच obstruct the electric current ए जो डेफिनेशन रो मान ए नुए जे पूरा पूरी टोटल करंट जदि कंडक्टर देख पास हुए ताको ऑब्स्ट्रक्ट कर दो टोटली तार माने ता नुए तार माने हला जदि अधिक परिमाण रो करंट गला जेति कि जीवा बदले रे अधिक परिमाण रो जदि करंट जाय ताको से ऑब्स्ट्रक्ट करे से जो न्यू एलिमेंट बा न्यू प्रॉपर्टी को कहा जाय इलेक्ट्रिकल रेजिस्टेंस सो फ्रॉम अबव डेफिनेशन we define a new term that term represents as a resistance which is generated from two things one is potential other one is current so potential difference across the conductor that is V which flows a unit ampere of current which is equal to a new term that is called electrical resistance and it is defined by R. So here V by I equal to R. So that means electrical resistance which is equal to potential difference across the two ends of the conductor where the current flowing through that given conductor in a particular circuit. Okay? But play तमे सब जानिछो Ohm's law. What do you mean by Ohm's law? Ohm's law says that at a given temperature, the electrical current which is passes through the given circuit which is directly proportional to potential difference across it. Okay? So from above definition from Ohm's law, we know that V directly proportional to I. जेते बेले करंट गोटे कंडक्टर रे जाय तार एक्रॉस रे कोन थिबार अछि पोटेंशियल डिफरेंस थिबार अछि okay so if you remove the proportionality then we get a constant quantity that can be represented as R into I so that R and that are quite different so here if you remove the proportionality then you use a constant quantity that represents as R and that remains constant when the material obey Ohm's law that's why that material behaves as a ohmic conductor in that case the resistance becomes constant otherwise it could not be constant okay jodi other konosi material naba tahale tar resistance केवल constant रहिबो नहीं किंतु जदि हमें ohmic conductor नबा tahale तार resistance सब बड़े constant रहेगा okay for different material resistance become different but in case of ohmic conductor resistance becomes constant whenever the current flowing through the circuit across the potential difference in between them at a given temperature that obey Ohm's law that given circuit obey Ohm's law so here for different material resistance becomes varying but Ohm's law according to Ohm's law in a ohmic conductor resistance becomes constant I'll define after 2 lectures okay please listen carefully this is the very important things okay so here V by I equal to R so R represent electrical resistance. Is it clear? Okay. This is the formula. So I'll find out the value of R. That means I'll find out the dimension as well as unit of R. Please note it. Units. We know R equal to V by I. V means what? V means potential. How to define potential? So V means whose unit is volt. I means whose unit is ampere. So R equal to volt per ampere is the unit of electrical resistance, or in another way we can define, okay, that is called ohm or ohm. So this is the symbolical representation of that. Okay. Okay. Ohm boli kahipariba. Clear? Now I will define dimension. What is the dimension of resistance? So R equal to V by L. We know V equal to what? W by Q. V means W by Q and I is here. So W means what? W means work done. Work done equal to force into displacement. By Q means what? Q equal to IT. So I T into I. So force whose unit is what? That is M1 L1 T minus 2 is here. This is the dimension of force. And S means what? The dimension of L. S means L divided by I into I, that is I square. I, unit of I, dimension of I is ampere. So ampere power 2. Is clear? Ampere power 2. And T means second. So time power 1 is here. Okay. So R, whose dimension can be represented as M1, that means L1, L1, that is L2. Here T minus 2 is here, in denominator T1 is here. So now T to power 1, which is going to numerator, that can be represented T to power minus 3 is here. A to power in denominator, now it is going to numerator, then it behaves as a to power 2 is here, minus 2 is here. So what is the dimension formula of resistance? Resistance whose dimension is M1 L2 T minus 3 A minus 2. Is it clear? M1 L2 T minus 3 A minus 2 is here. So please note it. Now I erase that thing. Now I will prove electrical resistance. I mean proof करिबा electrical resistance को. किमें proof करिया देखो. Proof. So we know I equal to NEA VD. You know that this is the relation between current and drift velocity. Clear? Similarly, drift velocity equal to, that means VD equal to what? EV by ml into tau. Okay, clear? Now this is the equation number 1 and this is equation number 2. Okay, so here putting the value of equation 2 in equation 1 we get. So what will happen? So I equal to NEA, VD means what? EV by ml into tau. Clear? Okay. So what will happen? That means I equal to N E square A tau by ml into V. Now I by V equal to that V which is going to denominator in left side. So N E square A tau by ml is here. Okay, clear? That means then that implies V by I equal to what? That is ml by N E square A tau. Clear, clear? Now that means V by I means what? Already I have defined. V by I means what? Electrical resistance. So R equal to, that is the R. V by I means what? Already I have defined. The V by I. The potential difference across the two ends of the conductor which flow the electric current so that it generates a new terminal, new element, that is called electrical resistance. So R equal to what? M by N E square tau into L by A. Clear? So R equal to M by N E square tau. That means that M is the constant quantity, the mass of electron becomes constant, and means number of electron per unit volume remains constant. That means electron density becomes constant. E means charge of electron remains constant, and tau is the relaxation time, which also remains constant at a particular given temperature. Is it clear? So all terms remains constant at a given temperature. Then that total term can represent as a new term. Clear? That new term represent as a what? Rho. Ako ame kon koiba? Rho boli koiba. Rho L by A boli koiba. Rho L by A. Here rho means resistivity of the material. Resistivity of the material. Okay? So resistivity माने कौन? Resistivity in the sense material रो nature को show करेगा. Okay? कौन करेगा? Material रो nature को show करेगा. Clear? So this is the relation between resistance and resistivity. R equal to rho L by A. So this is the proof of resistance. So here R equal to resistance of conductor resistance of material or resistance. Okay, R equal to resistance, rho equal to resistivity of the material, L is the length of material, and A is the area of cross section. Clear? Area of cross section. Resistance of resistance. R is the resistance. Clear? Please note it. So पहले एक चिंता करो ये जो R टा कहाँ पे डिपेंड कला? Please note it. I'll erase that thing. After that I will discuss about what is the basic condition of R, rho, L, A. Okay? Please note it quickly. Here, rho means what? Rho means M by N square tau. Clear? M by N square tau. And R equal to what? Rho L by A. So, R, which is directly proportional to length of the conductor. Okay? R directly proportional to length of the conductor as well as area cross section. That means L by A. R directly proportional to length of the conductor and R directly proportional to 1 by area cross section. Okay? Clear? But resistivity is the constant quantity. Resistivity is constant. How it becomes constant? Because mass of electron remains constant. N means number of electron per unit volume remains constant. E means charge of electron remains constant. Relaxation time also remains constant for a given temperature. Okay, so resistivity is constant. So how R depends upon L by A. देखिए, if we assume two copper wires, okay, if we assume two copper wires, so this is the copper wire 1, okay, second one is how to calculate, how to discuss, and second one is this is the copper wire 2, okay, this is copper wire 2, and this is copper wire 1, and that is quite small as compared to this one. Is it clear? So here you know that it has resistance, it has also resistance, okay, बुझिपार्छ. So if that wire, both wire remains same, that is becomes copper, that becomes copper. So in that given wire, first wire, it has proper length, that is this one, etik was tar length, and this one is the area of cross section. Is it clear? This one is the length and this one is the area of cross section. That means if we increase the length of that conductor, then area remains gradually decreases. Okay, area remains gradually decreases like that. If we increase, suppose this one becomes expanded, so this one becomes in that way. ये जो पेन टा केन देखागला याको एक्सपांड कली ये केन देखागला दिस वन एते बड़ लेंथ हेला तार अर्थ हला ये कोन हला आकु जेतळे मु एक्सपांड कली लेंथ बढ़ी गेला एरिया प्रोसेसिंग कोन हेला कमी गेला जेतळे आकु मु कोन कली कॉम्पैक्ट कली तार ये कोन हेला पेन नै गेला ए पेन रे कोन हेला लेंथ कमी गेला एरिया बढ़ी गेला तार अर्थ ए देखिले रेजिस्टेंस कोन होची का पर डिपेंड करछ लेंथ ऑफ द कंडक्टर एज वेल एज एरिया ऑफ क्रॉस सेक्शन ऊपर डिपेंड करछ क्लियर बट एमानकर वॉल्यूम कोन रहला सेम ही रहला तार्थ रेजिस्टेंस ऑफ द मटेरियल डिपेंड्स अपॉन लेंथ ऑफ द कंडक्टर एज वेल एज एरिया ऑफ क्रॉस सेक्शन बट वॉल्यूम रिमेन्स कांस्टेंट और लेंथ बढ़ो एरिया कम तार्थ वॉल्यूम सेम का रहला और लेंथ कम गेला एरिया बढ़ी गेला तार्थ कोन हला वॉल्यूम सेम का रहला तार्थ रेजिस्टेंस ऑफ द मटेरियल depends upon length of the conductor as well as area of cross section, but volume remains constant. Clear? Here, therefore, resistance of conductor depends upon length as well as area of cross section, but volume remains constant. Clear? Now pile ebi jiba resistivity clear. So हमें देखले रेजिस्टिविटी कोन अछि कांस्टेंट भाबे अछि ए रेजिस्टिविटी कहा पर डिपेंड करछि तार हम दीटा वायर नले गोटे कॉपर वायर और भी कॉपर वायर नले सो दीटा कॉपर वायर जेतल देखिले गोटे रो एरिया कमी जाइछि लेंथ बढ़ जाइछि आ गोटे रो लेंथ बढ़ जाइछि एरिया कमी जाइछि किंतु both are copper wire. So copper material behaves or indicate the nature. The material like as a copper which indicate its nature. That's why the nature of the material which represent resistivity. That means resistivity of the material depends upon nature of the material. Okay. So resistivity of the material depends upon nature. of the material. Okay, and also depends on temperature. Okay, similarly resistance also depends upon length of the conductor as well as cross section area cross section, but it is independent of volume. That means volume remains constant, but it also clear resistance also depends upon temperature. Okay, resistance also depends upon temperature. Similarly, resistance depends on temperature. Clear? Please note it. But you have to remember that resistivity of the material remains constant. It depends upon nature of the material as well as temperature. But resistance depends upon length of the conductor, area cross section, and temperature. Or that means given temperature. But volume remains constant. This is the notation. Please note it. After that I will erase that thing. Then I will discuss about effect of temperature on resistivity as well as resistance. Next पढ़िबा effect of temperature on resistance as well as resistivity. अर्थ देखिबा रेजिस्टेंस आउ रेजिस्टिविटी उपरे टेम्परेचर कोन प्रभाव पड़ुछ. ओके, सो इफेक्ट ऑफ टेम्परेचर on resistance as well as resistivity. So you know, for a given particular temperature, the resistance which is equal to rho L by A and resistivity which is equal to M by N square tau. You know that I have discussed. Okay, so if we increase the temperature, okay, then the electron inside the conductor becomes free. Okay, then the electron inside the conductor becomes what? Free. So they move very fastly. If you increase the temperature, then what will happen? Then electron moves very fastly. So they collide with each other in a few time. That means at a particular given temperature, there is a relaxation time is here. If you increase the temperature, their relaxation time becomes gradually decreases. That means then relaxation time becomes decreases. Due to decrease of relaxation time, due to decrease of relaxation time, what will happen? You know that formula. That is the relaxation time in the denominator. If you decrease the relaxation time, what will happen? Then what? then resistivity becomes what? Increases. That means tau becomes decreases, resistivity becomes increases. Now resistivity, which is directly equal to resistance, that means resistance also increases. So then resistivity as well as resistance become increases. Clear? Similarly, in another way we can define, if we increase the temperature, it contains second condition. Okay, if we increase the temperature inside the conductor, then many more atoms are there, so that electron inside the atom absorbing energy from that thermal temperature, they becomes energetic, so they release from that atom very fastly. Clear? Here ମୁଁ ତମକୁ ଗୋଟେ ଏକ୍ଜାମ୍ପଲ କହୁଛି। ତ ପୂର୍ବରୁ ପିଲେ କ'ଣ ଥିଲା, ଆମ ଗୋଟେ ପାର୍ଟିକୁଲାର କଣ୍ଡିସନରେ ପାର୍ଟିକୁଲାର ଥର୍ମାଲ ଟେମ୍ପରେଚର ଆମ ପାଖରେ କ'ଣ ଥିଲା, ଗୋଟେ ଫ୍ରି ଇଲେକ୍ଟ୍ରନ୍ ଥିଲା। କେତେ ଥିଲା? ଇନଫାନାଇଟ୍ ନମ୍ବର ଥିଲା, ମନେ ରଖ। ତାହିଁରେ କ'ଣ ହେଲା, ସେକେଣ୍ଡରେ ଆମେ ଯେତେବେଳେ ଟେମ୍ପରେଚର ବଢ଼େଇ ଦେଲେ ଇନଫାଇନାଇଟ୍ ତ ଥିଲା, ଏଗେନ୍ କ'ଣ ହେଲା, ଆଉ ଯେତିକି ବଳକା ଆଟମ୍ ରହିଲା କଣ୍ଡକ୍ଟର ଭିତରେ, ସେ ଭିତରେ ଥିବା ଇଲେକ୍ଟ୍ରନ୍ ଯାକ ଏଗେନ୍ ଏନର୍ଜିକୁ ସେ କ'ଣ କଲେ, ଅବଜର୍ଭ କରିକି ସେମାନେ କ'ଣ ହେଲେ, ଏନର୍ଜେଟିକ୍ ହେଇକି ରିଲିଜ୍ ହେଲେ। ତା ଅର୍ଥ ଇନଫାନାଇଟ୍ରେ ସପୋଜ ଆଉ 1000ଟି ଇଲେକ୍ଟ୍ରନ୍ ମିଶିଲା, ତା ଅର୍ଥ କ'ଣ ହେଲା, ଇନଫାନାଇଟ୍ରେ 1000 ମିଶିଲେ, ସେ ଇନଫାନାଇଟ୍ କାହାର ହେଲା? ଓକେ, ବୁଝିପାରୁଛ ମୋ କଥା? ତା ଅର୍ଥ ଏଇଠି ବି ଦେଖ, ସେକେଣ୍ଡ କଣ୍ଡିସନକୁ ଯିବା। ସେକେଣ୍ଡ କଣ୍ଡିସନ, ଓକେ, ସେକେଣ୍ଡ କଣ୍ଡିସନକୁ ଯେତେବେଳେ ଯିବା, କ'ଣ ହେଉଛି ଆମର number of electron density becomes कौन होगा, increase होगा। जेतल if you increase the temperature, then huge amount of electron becomes liberated, so they becomes free. Before, at constant temperature, if you assume there are infinite number of electrons are there, after if you increase the temperature, then more amount of electron becomes liberated, they are added to that infinite, so that becomes infinite, so n becomes increases, that means electron density becomes increases. Due to increase of electron density, what will happen? The resistivity of the material becomes decreases. Okay? And resistance become also decreases. That samudra re ame jodi gote bunda pani kuade deba, samudra pani kon komi jibo ki? So that second condition is not significant. It's quite less good as compared to this one. Okay, that's why that condition is not too good as like as this one. So that condition becomes contradictory, or that condition is insignificant. Clear? But that condition is very good significant. Okay, so from above conclusion, we notified that if we increase the temperature, then relaxation time becomes decreases, so that resistivity as well as resistance of the material becomes increases. That's why if in case of conductor, if you increase the temperature, then what will happen? Resistance as well as resistivity of the material becomes increases. So resistance and resistivity becomes increases in conductor while increase of temperature. Okay, जदि आमे गोटे कंडक्टर को ह्यूज अमाउंट रो टेम्परेचर दबा particular given temperature जदि बढ़े दबा ताहले तार रेजिस्टेंस एज वेल एज रेजिस्टिविटी से कोन करिवो इंक्रीज करे दबो ओके so that if we plot a graph between resistance as well as resistivity with temperature, that's right, temperature along x-axis and resistance r or resistivity along y-axis, this is the y-axis, so the graph is like that. So the graph becomes this one. So this is the graph of resistance or resistivity with temperature in case of conductor. For conductor. Clear? Please note it. आपको हमें कंसीडर करियो ने प्ले सेकंड कंडीशन को तेणु मु इट क्रॉस कर देली ओके तुम एटा लिखले लेख नले छाड़ दियो मु तुम बुझिया पे कहली छाड़ दियो हला please note it. After that I will erase. Next thing is semiconductor. So you know in electronics Makan sir is told that what do you mean by semiconductor? Semiconductor means it is a material which carry electricity partially. That material behaves as a semiconductor. You know, pure semiconductor like a silicon and germanium behaves as a pure silicon, pure semiconductor. Okay, silicon as well as germanium behaves as a pure semiconductor. Okay. Now, here in semiconductor case, okay, in semiconductor, we know the electrons are moving partially, that's why they carry current partially. So here in that case we know that formula rho equal to m by n square tau. That means पूर्व कौन थिला कंडक्टर ह्यूज अमाउंट रो इलेक्ट्रॉन थिला फ्री भाबे बुझी परछो दैट इज इनफाइनाइट नंबर रो इलेक्ट्रॉन थिला एबे कोन हला सेमीकंडक्टर कोन होची पार्शियली इलेक्ट्रिक करंट जिबा जोगु तार तो फ्री इलेक्ट्रॉन कोन अछि कंडक्टर जे जेतिक रहिबा कथा ताटर ये कोन रहला कम रहला सपोज इन कंडक्टर इनफाइनाइट नंबर रो इलेक्ट्रॉन फ्री भाबे थिला बेले आइ कोन अछि सपोज 1000 टा इलेक्ट्रॉन अछि ओके सो नंबर ऑफ इलेक्ट्रॉन कोन अछि 1000 टा अछि क्लियर now this is the very important thing, please note it. So if we increase the temperature, if we increase the temperature, then what electron density, that means number of electron per unit volume becomes increases, then number of electron per unit volume becomes increases. Clear? You know n and r both are inversely, n and rho both are inversely proportional to each other. So resistivity as well as what, that means r equal to rho l by a, you know, as well as resistance becomes what, decreases. Clear? Okay, decreases. That means what, n becomes increases R decreases, rho also decreases. If we increase the temperature, the number of electron per unit volume becomes increases, so resistivity as well as resistance becomes decreases. This is the very important things as compared to what? I'll discuss that thing. Okay, second condition. Second condition is, if we increase the temperature in a semiconductor, then relaxation time becomes what? Decreases. Clear? So that resistivity as well as resistivity and resistance becomes increases, but is not significant as compared to this one. But is not significant as compared to this one. Okay, बुझिपार्छु पहिले ये काहे सिग्निफिकेंट हुए काहे कि हम सब बड़े नंबर ऑफ इलेक्ट्रॉन डेंसिटी को धरी बा नंबर ऑफ इलेक्ट्रॉन पर यूनिट वॉल्यूम को धरिबा तो प्रथम केस रे कोन होतला नंबर ऑफ इलेक्ट्रॉन पर यूनिट वॉल्यूम इनफिनाइट ही थिला ताइर इनफिनाइट मिसी गला ताइर आ किछ मिसी गला तार तो से इनफिनाइट होला तेनो से सिग्निफिकेंट होनथला जति सेटा सिग्निफिकेंट हेइथांता आमे से रीजन से कंडीशन को ही इंप्लीमेंट करथांता कोडी कंडक्टर रे जेहेतु सेटा सिग्निफिकेंट होनी तेनो आमे सेकंड कंडीशन को फर्स्ट कंडीशन को कोन कले इंप्लीमेंट कले जोडा कि दिस वन जेहेतु सेमीकंडक्टर केस रे तमरो n कोन होची सिग्निफिकेंट होची फर्स्ट कंडीशन तमरो कोन होची सिग्निफिकेंट होची दैट मींस नंबर ऑफ इलेक्ट्रॉन पर यूनिट वॉल्यूम becomes increases but it is not infinite. Clear? That means electron per unit volume becomes increases due to increase of electron per unit volume, so that resistivity as well as resistance become decreases. This is the very important result, very important points as compared to this one. So that becomes significant and this one becomes insignificant. We can't observe that condition, so that condition becomes wrong. From that condition is too correct, so we have assumed that condition. Okay, so in that case এটা লেখিলে চলিব ন লেখিলে চলিব তুমি বুঝিয়া পাই করিলে লেখন हैला so resistance as well as resistivity becomes what? Decreases. While increase the temperature on semiconductor. Sorry, temperature in case of semiconductor. Clear? So this is the very important point. Okay, please note it. This is the significant. So this is the very important point. So in case of semiconductor, resistance as well as resistivity becomes decreases while increase of temperature. Please note it. Okay, please note it. आकु लेखनी खाली बुझिया पे कहली तुम. ओके, एटा को लेखो पहले आकु इरेज कर दोछि. So if you draw a graph between temperature along x-axis and resistance or resistivity along y-axis. So the graph like this one. This is the graph, because if you increase the temperature, resistance as well as resistivity decreases. So in case of semiconductor, it will happens. Semiconductor, yes. Clear? एतिकी लेख तापर ग्राफ टा ओके LOS. So LOS are those material, they are less affected by the temperature, very less affected by the temperature. Okay, so that type of material which are used in many practical purpose, which are used in meter bridge, potentiometer. Okay, so example of alloys are constantton, manganese, eureka. Okay, clear? So alloys are those material which are very less affected by the temperature. Clear? So that material given as compound like as number of manganese, constantton, okay, then as eureka. Okay, these are the things, manganese, constantton, etc. Okay, so and second thing is these materials which are used in many practical purpose. Clear? Please note it. Very good, important thing. Now if you draw the diagram, okay, so here resistance as well as resistivity does not affect by the increase of temperature. Clear? Here resistance as well as resistivity does not affect by the increase of temperature in case of alloy. So if you plot a graph, temperature along x-axis, resistance or resistivity along y-axis, so it likely very less affected. That's why so प्रथम हम छाड़ दो एटू हम ग्राफ आनिबा. This is the graph of resistance as well as resistivity versus temperature graph in case of Ly. Please note it. Clear? Okay. Next one is unit of resistivity. Units of resistivity. You know the formula. We know R equal to rho L by A. Okay, that implies rho equal to what? R A by L. So rho equal to what? R A by L is here. So R means his unit is ohm. A means meter square by meter. So meter cancel out. Ohm meter is there. So resistivity, whose unit is ohm meter. Clear? Then dimension. What is the dimension of resistivity? So here rho equal to RA by L. Already I have discussed the dimension formula of resistance. So what? M1 L2 T minus 3 A minus 2 is 0. Okay? যদি তোমার ডাউট লাগুଛି তুমি কাঢ়িପାରିବ. So R মানে কোন थिला? That means V by I. V মানে কোন? W by Q into I. W by Q means what? Q means IT into I. So what? W means Fs by I square into T. That means F means dimension M1 L1 T minus 2. So dimension S means distance, that is L1. What? I means I square means A to power 2. T means T to power 1. So we can define M1 what? L2 T minus 3 A minus 2 is here. Okay, this is the dimension. Okay, this is the dimension formula. So if you put the value of resistance in the form of dimension, okay, into area means what? L to power 2 is here, divided by what? L to power 1 is here. So L1 cancel out, so only one L1 is there. So M1 L2 T minus 3 A minus 2 into L1. That means what? That means rho equal to, that implies rho equal to M1 L3 M1 L3 T minus 3 A minus 2 is the dimension formula of resistivity. Clear? So this is the dimension formula of resistivity. Clear? Please note it. M1 L3 T minus 3 A minus 2. Okay? Please note it. So here I have discussed all these things like as electrical resistance and effect of temperature on resistance as well as resistivity, and also I have derived unit and dimension of resistance as well as resistivity. If any doubt, then ask me. Okay, please like and share my video. Thank you. Bye bye.